Hey guys, welcome back to Home Built, and this week we are back on the Frankenhauler and we are getting down to the nitty-gritty of the final design of the tilt tray for the back. All right, guys, welcome back. And if you did watch last week, you will have seen that I sorted out the lighting for the front of the Frankenhauler. If you missed it, I'll put a link up above so you can catch up and do those things. Like and particularly comment. That stuff really does help out the algorithm. So last week, there were lots of suggestions about the front end, what I did. If you're watching, you will have seen that I made this this sort of light bucket for the lower indicators, and I had some trouble with the press tool that I made. There were lots of people who suggested I 3D print that light bucket. That would have taken way longer than it did to make that piece. Obviously, a 3D printer takes some time to print, but 3D design is very, very time consuming. Designing in CAD in 3D takes a lot of time and a lot of effort. It would have been much more difficult to do that, and it wouldn't match the other side. I mean, I could make two, but like I had one, I just needed to make another one. I was much happier making it in steel, and it was pretty good. There were some suggestions about the press tool that I made up to try and make the screw mounting points for either side. That I could have tried to use heat to try and make that steel a bit more malleable so it would work better in the press tool. I didn't try that, but that might have worked. There were others saying that pre-stretching it might have been good, like run it through the English wheel or something like that first would potentially help it be a bit more malleable, and using different steels and stuff. But either way, I was trying to do it in the most efficient method, and that was efficient. Besides maybe heat, that was a very efficient method, and it worked, and it's done, and I'm quite happy with it. Now, there were lots of people concerned about the indicator not being visible. It's only hard to see when I have the park light on. Now, there were suggestions of park lights that are like dual globes that change from like a white parking globe to an amber flash when it's indicating. I might look at doing that. As I said, like there's no issue seeing it while the park lights are off. It's only while the park light's on. Now I could put a little stainless steel barrier inside so I can sort of separate out the globes, which I may do. I can also put in a second amber indicator light on either side of the park globe so that they're a little bit more illuminated. I'll take it at a later date, but for the time being, I'm happy with the front of the truck. It will do, besides maybe doing a little bit more sort of alignment, because the bonnet gap here now seems to be higher, bigger than it was before, and we'll sort that out. As far as moving forward goes, we want to really flip the truck around and start having a look at the back so we can start designing the tilt tray and show you what I am sort of currently thinking. All right, well, before we get onto the back, I just quickly want to go back to the rear window. Like you saw, I actually tore the rubber in a couple of spots last week when I was fitting this rear glass in from the inside, not from the outside, so it actually worked. And there are a couple of suggestions. Apparently, super glue is really good for the rubber. It will work quite well, so I'm going to use some super glue and fix these rubbers, and then we can start talking about the rear tray.
So it's things like this that I'm extremely grateful that I have you viewers watching my back, and when you see me do something like this and you know that the window needed to go from the inside, it's so good to have you giving me these suggestions and save me weeks of headaches trying to work out why the window wouldn't go in properly. But a bit of super glue here and we are all fixed.
All right, let's get into the meat and potatoes of this, and that is the tilt bed on the Frankenhauler. Now, if you watched my episode a month or so ago, I was talking about my previous design was a total winch system where I had a frame on the back of the Frankenhauler. So let's do it in this orientation. So there'd be a frame that lay on the back of the Frankenhauler and the bed lay on top of that, and there'd be a winch that would pull it backwards until it got to a tipping point, and then it would tilt and hit the ground, and then it would just keep winching the tray down. And it was using a trolley and all this sort of complicated, heavy mechanism to do that. And I was overcomplicating everything. I was making everything very big and very complicated and much more difficult than it needed to be. And by the end of that time, and after discussions with my engineer, I went let's keep it simple. And my plan was, let's keep it simple. Let's just make a tilt tray and basically just have it hydraulically raised and lowered, and then just have two pull-out ramps that I can just pull out and sit behind the truck. And I'll have a 2 3-meter ramps. I'll have a nice smooth transition to get onto the tray of the truck. Most of this was keeping it simpler and lighter, and there were lots of you who agreed with me that just keeping it simple and lightweight was the way to go. But there were others that did make a valid points, is that it's simpler and quicker to do just the straight tilt, but to do the tilt and slide, let's face it, I'm not in a hurry. You guys seem to be engaged and enjoying watching this, and I'm enjoying building it. So do I need to rush it? Do I need to get it done quicker? Not really. So I'm going again back to a slide type bed, but I've got a new plan. And a lot of that came from one of my mates, Adam, who has a very high-end car transport business. He has like enclosed trailers and trucks and things for like super exotic multi-million-dollar cars sort of around Australia. But he showed me this video of a car dealer who has this much simpler slide bed system on one of their trucks.
So at first glance, this probably looks a lot like the plan that I had before to build this, but this is a very simple system. It's just use the hydraulic ram to push this frame up in the air, and then the tray itself is just sliding back on Teflon boat slides. And you can just see it's got a winch that is releasing it, and now it is actually the weight of the tray pushing the truck forward in neutral, and it slides all the way along and actually all the way off the end and flat onto the ground using a pulley system. And if you have a look here, you can see it actually used these Teflon boat slides, and you can see the pulley system with the cable to lift the entire unit back up again, and then the hydraulic ram that lifts up the frame on the back.
So after seeing that system, I really like the simplicity of it. It's just basically using gravity, as you could see. Basically, it just had a hydraulic lift, and then gravity just let the bed slide down. And that particular one went flat on the ground. Now, I don't love that design because that flat tray on the ground still sat up, at least 100 mil high, which meant that a lot of low cars, you still need to get that tray all the way off, all the way behind the truck, and then you still need to pull out ramps to get a low car on, and that's defeating the purpose of what I'm trying to do. I'm trying to be able to get the tray set up so that I can get a low car straight on without ramps or anything. I just want to be able to get it straight up. Now, if it's super low, like it had a cup car or something with a big low splitter on the front, then maybe we might still need ramps. But for regular street cars, I want them to be able to get straight on, no dramas, And that is where my current plan is. So what I'm looking at with the back of the Frankenhauler is I am going to have a 4.5 meter tray. So it's not a huge tray. Basically, it's around the length of most of my cars, so they will just fit on the back. But again, I am building a lightweight vehicle that is going to be on a car license, and it's going to have a GVM, a gross vehicle mass, of under 4.5 tons. So you can drive on a car license, and that means that this is hopefully, when I'm all said and done, the whole truck should weigh around 3 tons. That's what I'm trying to aim for. And that means I can carry up to 1.5 ton of car on the back. All of my cars are light. They are way under that anyway. So that's sort of the perfect option for this whole setup. Now, I do have a truck license. I could do it on a truck license, but then none of my mates can borrow it. Let's keep it simple. Let's keep it so that anybody can drive it and we can just use it. Now, the rules in Australia on what you can build, there is an overhang limit. Now, believe it or not, the Frankenhauler, the Toyota Coaster bus that it's built on, doesn't actually have a very long wheelbase. The wheelbase is 3.9 meters from center of the front hubs to the center of the rear hubs. And the maximum rear overhang on any vehicle in Australia, any rigid vehicle, is 60% of the wheelbase behind the rear axle. So for this truck, what that means is that I can do a 2.34 meter from the back from the middle of this axle to the back of the truck. It's 2.34 meters of overhang. Now, I am planning on slightly less than that. Basically, I want this 4.5 meter tray. Now, after my calculations, I roughly set it up to try and be 2.25 meters to the cab. As some of you saw, the cab is slightly further forward by where the wheel position is in the truck. But again, that was all to help this. So currently, from the center of the axle, I am 2.22 meters from the back of the cab to the middle of the axle. So that means that I can go 2.28 meters behind, and I can go to 2.34. So with that overhang, that means that the back half of the tray is going to come to about here. So that is the end of my tray. Now, the next thing I've got to look at is to make the transition to get a car onto the back nice and flat. What I'm going to do is, instead of having the pivot, if you're imagining this is the frame for the tray, instead of having the pivot at the back of the truck, so then when my bed slides all the way off, the front of it would be up here. That's still quite high. But what I'm going to do is I'm going to cut off the back of this frame, and I want to set up the pivot so it's further forward. So then when I lift the front up, the back drops down and it gets quite close to the ground. So then over 4.5 meters, it's a negligible slope, and it's quite easy to get vehicles on and off. So that is my current plan, is to try and sort out that. So to do all this, one of the first things I need to consider is, where is my tray going to sit on the back of the truck? Now, I do plan on actually lowering this truck. I've already talked to a company. I can reset the springs, the leaf springs. These are super stiff. Talking to Jay Low Standards, who has built a similar truck, and they make almost zero deflection with a car on the back or not. They're designed to carry a lot of weight, and these springs are not going to sort of buckle under the weight of a vehicle. They'll be more than sufficient. This was designed to carry 22 people, and now I'm only carrying little cars. And if you actually calculate it out, it's fine. This actual bus was owned by a friend of mine, and I rode in it a few times with about 20 large men inside, and didn't bottom out at all. It was still rode totally fine. We didn't even notice it. So it's more than capable of carrying my little cars. What I need to factor in is over the biggest bump that this truck could have, these tyres need to be able to come up and not hit the tray. So I need to factor in 0 bump stop and the height of the axle, and the height from the U-bolts to the bump stop point is about 165 millimeters. So in theory, these tyres from the top here, the most they can travel up in a bump is another 165 millimeters higher than where they are now. So that means that roughly that is the minimum height I can make the height of the tray. And again, I want to make the tray as low as possible, all in an effort to get it easy to put cars on and off. So that is my minimum height for the bottom of the tray. Using this level, that this is the current height of the existing tyres, and we need the tray to be 165 mil higher than these tyres, and the current height is about 24 millimeters. So let's say 25 millimeters plus 165 millimeters takes us to 190 millimeters, minimum 190 millimeters. Let's make it 200 millimeters to make it a nice even number, but also give me like that little extra fraction of allowance. And I'm going to have some bump stops in there, which are going to be small and other things, but we're talking tiny amounts for total wheel travel. I'm quite happy with that. So my tray height is going to be 200 millimeters, or the base of the tray is now, I'm planning on making it 200 millimeters higher than this part of the rear chassis.
And now we start a whole bunch of measuring, and there is so much measuring before I start this project. I really need to know where everything is because the frame is in 3 different sections, so there's 3 different levels in the frame, and the frame's not necessarily level with the cab either, so there's a lot of calculations before we start.
All right, so one of the next measurements I need to calculate and need to work out to organise and sort of come up with this tray method is a hydraulic ram, and that's what I've gone and got. I've got a 24-volt hydraulic ram setup. Now, this one is a 5-stage hydraulic ram, which designed for a tipper, which I think is overkill big time for what I'm actually looking for. I think this will tip far higher than what I want, and that means that I need to think about how I mount it and how I do it, but I need to know what the lowest height of this ram is and what the highest height of this ram is. So I think that means I have to actually connect it up and run it and pump it up, and we'll see what it actually, what height it actually gets to, and then I can add that all into my calculations.
So I bought this ram online, and although it comes as a tipper kit, there isn't actually any instructions with it. So I had to do a little bit of research online and sort of working out where I needed to connect the positive and negative cables, etc. But mostly this is pretty straightforward stuff. And then I just need to give it a go, and I used my 12-volt power probe just so I'm not going to be damaging the system if I connect things up incorrectly, and I worked it out. So now I can connect up to a 12-volt battery pack directly and fill it up with some hydraulic fluid, and then we can start trying to run it through its paces. Now, I don't exactly have enough hydraulic fluid on me to fill it up, but we've got enough to get it started. So as you can see by the way this is bouncing, that it's got a lot of air in the system, but we get the idea.
All right, so I've very quickly set up my ram. Now, I don't actually have enough hydraulic fluid. I think some of this is actually just pressurized air that's in this line at the moment. I think it's actually, yeah. It's obviously not pressurized by fluid, but that's fine. It's giving me my total height, that's the main thing I need from this setup to start with. And I'm currently only running it on 12 volts, and it's running on 12 volts, but it's a 24 volt pump, so it'll run on the 24. Yeah, so 1.45. So this gets very high. So now I have my measurement all the way up and the measurement all the way down. I know the travel of my RAM. I need to work out then the travel of what I want to make the tray. So let's start doing some calculating for that. And then we need to work out where we're going to put our pivot point so that we can work out all the rest of the lengths and measurements. So much maths that you never knew you needed when you left school that you would actually come back to.
So now I have to put the RAM back away again. It's probably not a bad thing that it's mostly full of air, because it would have been a lot harder and taken a lot longer to let all of the fluid out if it was full.
All right, so I've worked out a bunch of my measurements, and I've done some mocking up here just so you can get a bit of an idea. Now I have this piece of timber. It's not long enough. The tray will continue further out, but that is the height of the base of the tray that's going to be sitting on here. So the cars are going to be sitting up on that height. That is the absolute lowest I can go, so that these wheels at full bump, whenever it goes, will not touch. Now, I am going to be lowering the truck. So the truck will be getting lower than what it currently is by about 75 millimeters. Now, because I know that that is the height that I need, and I need to have a frame that is attached to the chassis that can lift up and down, and that will just hinge up and down, and then I actually have the tray that sits on top of that. So I've been doing a bunch of measuring and calculations, and then I did some more again, which really probably mean nothing to you, but what I'm working out is I want the frame to tilt and pivot so that the back edge of the frame gets closer to the ground, and then the tray comes all the way off, so it's only the front edge of the tray is sitting at the back edge of the frame, so that the angle to the ground is nice and low. And one of the stumbling points of making that frame, go all the way to the ground is I would like to keep a tow bar on the back of the truck. If I can keep a tow bar, then it's still usable. I can still carry a vehicle on the back of the truck, and then I can also put a car trailer on it and tow another car behind it, so I can actually take two cars to places if I needed to. And just having a tow bar just is a very useful thing. Now, I was looking at all different versions of how I could put a tow bar on. If you look at Puddin's Fab Shop, he copped a bit of flack because he actually mounted his tow bar to the tilt bed. The drawbacks of doing that is that all of the force of the tow bar goes through the hinges of the bed. And that's not really what I'd want, and I don't think I would actually get that passed by the engineer. I did look at other methods of getting the tow bar to move and move with the tray. I don't want to have a removable tow bar that I have to remember, go and take that tow bar out before I tilt it. I want to be able to tilt it and not forget and not damage things. So that is not an option. So with all my calculations, what I've worked out is I can keep a tow bar. The ball, when it is fully loaded, needs to sit in Australia between 360 millimeters and 450 millimeters off of the ground. That is the Australian design rules. That's to keep the trailers nice and level, etc. So if I have the unloaded ball if I work it on being 450 millimeters high, so the highest it can, basically I want the frame to be able to pivot and go down, and the ball sit in between so that it doesn't actually get hit by anything, and I can still slide the tray off with the tow ball not interfering. So what I've calculated is I'm going to make the lowest part of the tilt frame 500 millimeters off the ground. So with a 450 millimeter ball, and even with it 500 millimeters here, and the ball's a little bit further forward, the the tray will be able to slide straight over the top and totally not be interfered with the toe ball. Now, I did calculate out the angle of the tray on the ground, with the front edge being 600 millimeters high. If my maths is correct, I think it's 7.66 degrees of angle. And I think one of the lowest cars on some sort of C8 Corvettes is like 8.5 degrees approach angle, and I'm going to have 7.6. So it should be able to get pretty much any street car on there without any problems with the approach angles. All right, and you can see here, this is a visual representation of the angle of what the tray is going to be. So that approach angle is extremely easy. I'll be able to fit basically any car on there without any real dramas at all. So I'm going to mock this up quickly and double check that my measurements are all accurate, and then we can go and start making a shopping list for the steel I need to build this frame.
So before I commit to everything, I am mocking things up just with a piece of timber, just to make sure my measurements are not a mile out and that they're pretty close to the mark. And so far, so good. It all seems to be working. All right, so we're down at the local steel yard. So let's see what we can find and load up the trailer. Thankfully, my steel supplier is only about 5 minutes from my house, which makes life very easy when I need to go and get some more. But here, I'm pretty sure I've got almost everything I'm going to need to build my tray, besides the actual flat bed of the tray itself, which is a really good sign because I barely even noticed it towing the trailer. Now, I did go reasonably lightweight on all this stuff. I used my existing car trailer as a bit of a guide for the level of steel I'm going to need, but I've erred on the lighter side, and if I need to beef it up, it's always easier to add more than it is to cut it out.
All right, so I have a bunch of steel ready to go, and this is my initial mock-up of the frame for the tray. So the tray is actually going to sit on top of this. This is where the Teflon slides are going to go onto. I have my measurements. I actually set up a straight edge, a piece of the steel on the ground, just to double check, because my shed is not perfectly level, so we're not going off of that. And I've got my level on here. I've put a couple of tape marks on the back of the cab to mark the height of my beam. So the next thing I need to do is work out the hinges. Now the hinges, I've worked out my hinge point is here. Now I could have made hinges, but I actually found these relatively cheap online. They're rated to 10 ton, so I just went ahead and got these. But they're still short of where they need to be by about 32 or 33 mil. So I need to make a standoff for them to actually build that up. I also need to cap in these rails because there's going to be the weight on these rails. It's only going to carry the weight for the short times when it is tipping, so it's not going to be carrying all the weight when when you're driving down the road. So when it's bouncing on it and creating heavier weights.
So after this episode of constant yapping, I am finally actually doing something, and I'm going to start by trying to cap in these rails for the back of the truck. And you can see here I've cut off a length, and I'm actually sort of cutting it out to make a C-section, and then grinding everything back and making sure it all fits in so that I can basically box in this frame and reinforce it all. Using the grinder go round, get rid of all the blue, so I've got a nice surface to weld, and also get rid of all of the black paint off of the chassis. Obviously this will all get touched up and repainted at a later date, but I am very happy with this. So measure, mark it. Now I can tack it, and then I can start looking at welding the whole thing together. I think my MIG welding is going to get a lot better by the end of this job because I've got a lot to do, but for the time being, it's not too bad. But yeah, more practice would be better in the MIG welding stakes. I do so much TIG welding now, I'm out of practice.
amazing. All right, I've been looking at getting a cold cut saw for a long time, and I finally bit the bullet. A big thank you to the Patreon members who've helped me get some tools for the garage, and this being another one of them. And cold cut saw so much better. It's just so fast and clean and quiet compared to the big abrasive disc saw that I've used in the past. That thing is horrible, it's noisy, it's messy. This is just quick and easy, cuts through like butter. Cannot recommend it highly enough. Yes, fantastic. Thank you, patrons.
So again, I'm cutting off the back edge of this rectangular tube, and I actually messed up the first time because I actually cut off the flat edge, and this time I did it correctly and actually cut off the seam edge. So definitely keep an eye out for that, and I'd have to do that in the future. But going around, cleaning everything up again, making sure I have a nice clean surface to weld to, and then with a bunch of measuring and some tacking, I get it all nice and square and straight before going through and trying to do some nice big continuous runs. And that was reasonably smooth, definitely better than the first run. Again, practice makes perfect with welding, so the more you can do it, the better you get.
All right, they are boxed in on both sides. Not my greatest welds ever, but they will definitely do. And I am happy with that. So we have a start. All right, so it's not much, but it is a start. And we have a plan moving forward for the tray of the Frankenhauler. I am very happy with the way I'm moving forward on this. It probably doesn't make a lot of sense right now, but once we get into it next week, we're full steam ahead. We're going to start building up the standoffs and hopefully building the tilt frame of for the Frankenhauler. So hopefully you join me for that. I am really excited about getting into it. Now we have materials, we have a plan. It's all so close to getting going. So hopefully you join me on that. But that's all the time I have this week. So I think that means it's time for Fun Facts with Mrs. Jeff.
Hey guys, in 1962, Ford of Britain released the Cortina. It was designed by Roy Brown Jr., who had been banished to Ford in Dagenham, UK, after the failure of the Edsel, which he had designed. It was named after the Italian ski resort, Cortina d'Ampezzo, which was the site of the 1956 Winter Olympics. Initially, the Cortina came with a 1.2-litre four-cylinder, which was upgraded a few months later to a 1.5-litre for the Super. It was available as a standard, deluxe, superior and GT, and as either a 2-door or a 4-door sedan, and also as a 5-door wagon. There's also the option of faux wood sides. The Cortina proved extremely popular and was manufactured in the UK, Singapore, the Netherlands, New Zealand, and of course Australia, in Broadmeadows, Victoria.
All right, I am very excited to move forward and start making this this tilt bed. I am, I've been thinking about it for ages. Like, I wake up in the middle of the night and I'm sort of working out what methods of how I'm going to mount everything and get everything to tilt and slide and do all the bits. And I'm pretty confident I've got it worked out, and it's going to be a pretty good result. I think so. I'm enjoying this. This is going to be good.
It's going to be great. I can't believe it's going to be finished soon. This has to be one of your quickest projects.
It's definitely up there. I mean, there's still a bit to do, but I haven't trimmed the interior. I haven't done underneath there's stuff to do, but the basic concept is getting there very quickly.
Ooh, we'll see. All right, well, like, subscribe. Jeff, help him out on Patreon, of course, if you want to watch videos a day early as well with no ads. And
join us next week
see
for
what happens. Yes,
more excitement building the tray.
Journey.
All right, guys. See ya.
It was designed by Roy Brown Jr., who had been banished to Ford in the UK to Dagenham, by Roy Brown Jr., who had been banished to Dagenham, UK, to Ford in Dagenham, UK.
Is Dagenham how you pronounce it? Dagenham? Dagenham.
I said Dagenham, didn't I?
Yeah, I don't know.
I think that's right.
I don't know. You
Look it up on your phone. How do you pronounce Dagenham? I think it's Dagenham. Pretty sure that's how I've heard it said.
Dagenham.
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 Okay, I'll do it again.
Dagenham.
Dagenham.